Hello and welcome to yet another exciting webinar with SOM Survey instruments and 3Dsurvey. In today's webinar, we'll be discussing how to use your PPK drone data in 3Dsurvey. But before we continue, I just really want to thank you for the time and effort you have placed into watching this webinar. And I really hope at the end of this webinar, there's something new that you have learned today. So, my name is Viam Labaskachny and I come from a company called SOM Survey Instruments. And together we pride ourselves in giving you, as the surveyor, the most powerful, precise and cost-effective surveying solutions out there. So if you haven't checked out our website, be sure to do so and stay on top of your game. So let's talk about the reason why you're all really here today. In today's webinar, you can expect the following content to be covered: the basics of PPK data, starting a new project in 3Dsurvey with your PPK data, and the basic overview and workflow of using your PPK data. We'll also be covering how to compare a point cloud with some additional points after you have processed with your PPK data, and then shifting your point cloud if you did not make use of any GCPs at the beginning to the relevant GCPs. Getting a mean and doing a major shift at the end of your point cloud. We'll also be speaking about more comparing the data after the shift, and then creating contours, generating an ortho photo of your site, and then exporting that data to Google Earth. Awesome. So without further ado, let's jump into the webinar. I'll be turning off my camera, but be sure that I have not turned into a ghost. I'll be seeing you at the end. Enjoy it. Alright, so as you know, this is the first screen of 3Dsurvey. So what we'll do is we'll click on New Project. We'll navigate to our relevant webinar project. For example, if you have your other normal field data, over here you can actually see what we have used. We've used the MLIT M2 with a RS2 base, and also we used our own SOM complete RS2 kit to actually pick up all the coordinates on the ground. And over here you can see there's a base file, there is a rover or drone file, and then as well as our images. So just to actually see what the difference was from the original images compared to the move, we'll go to details and we can actually see the coordinate. So 1374 is what we need to remember, and then let's just go to the results of the tagged images. We can just go there. So details, so 1374 is what we need to remember, and 1462, as you can see, is the corrected value. So there was quite a big adjustment done on all the photos, but we're glad. So let's just click on this selected and corrected PPK data. And obviously that what we have looked at currently is the reason why we make use of EXIF data, because those coordinates is inside the photo located as EXIF data. We've got a known projection. On our previous webinar, we showed you how to use the South African coordinate system, and because we know what coordinate system it's in, we can just go ahead and select it, import the data, and we can see that the data was imported successfully. We can click on OK, and we can actually just see all the coordinates as they are listed here. So one thing that we normally do not change if we don't have PPK data is the X, Y, and Z precisions. But because we actually do have PPK data, we can set this to the desired accuracy that we actually want. So for example, what we can do is we can manually set this precision to, let's say, 0.04. We can even make it smaller, 0.04, and over here on the Z we can select it as 0.05. Alright, so we can even make the X and Y positions smaller, but I think for this case it's fine. We'll just use it as it is. We'll click on confirm. As you can see, the precisions of each photo has then been updated, saying that that photo position accuracy is within 40 millimeters or 4 centimeters, and we're fairly happy with that. So we'll click on close, and then our next step we have to do is do a basic bundle adjustment. So we'll use the global for this. I must say in most of our projects, because it's survey orientated, we use global because our data sets are normally quite a bit big. If you have 1,000 photos to bundle adjust, but you're using sequential, it might take almost double the amount of time. So we just want to avoid that, so we use global, as it's just faster to do the bundle adjustment. Okay, as we can see, our bundle adjustment has finished. So the next option we have is to either go directly to reconstruct our job, which means that we will not make use of any GCPs at all. But in this case, we actually want to make use of some GCPs. So we'll go ahead and then just click on Orientate with GCPs. And then, sorry, just browse for the file. We'll click on this one and use this GCP file. So we just want to use 3 GCPs. Even though the site has got 9 GCPs, we want to use the rest to check on and just also validate that the new pointout is actually correct. So again, we make sure that we are using westing, southing, and the elevation with the name there, and we use the known coordinate projection, which is Hartbeespoort 940829. We'll click on import, and our diameter of the targets that we have used is 270 millimeters or 27 centimeters in diameter. So that it just means that the black dot on the white target is 27 centimeters. This is fine with us. And over here you can see that there is GCPs or validation points. We're going to keep everything as actual GCPs. I'm going to say next. And over here we're going to select our first real GCP. And then just go down and select our second GCP. Okay, and then again, we'll just be looking out for a small green dot. As you can see, there it is already. Let's just continue a bit. There we go. Alright, so we're just going to click in the center there. And as you can see, this is my general accuracy. I'm going to keep the detect GCP function on. What this means is that 3Dsurvey will automatically center my targets on the ground because we are making use of 3Dsurvey targets. If we weren't, obviously the function will not be relevant to the work. And if you do not tick this, it will not place the cross exactly on the target, and you'll have to do some manual adjustment. So, but because we did make use of 3Dsurvey targets, we'll just click on detect the GCP targets, select next, and as you'll see, it will detect it automatically, and we can see that it's automatically spot on in the center, which will make this step extremely fast. I might just activate that one, and we'll just say next. So if this was not the case, the GCPs would have not been aligned as they were and centered already. So it's always nice to use the 3Dsurvey targets so that you know that your workflow is so much faster. Okay, this is the total error, and we're pretty happy with that. We're just going to say finish, and then confirm the error. 6 mils is our worst, which is fine, and go over to a reconstruction. We're going to use a medium level, and we don't need to make use of surface-based optimization because we've got a graphics card. So we'll just say on OK. So that's it. So the dense reconstruction will happen now, and as soon as we're finished, we'll do some checks on the PPK data to make sure that the GCPs we have used is in actual fact correct. So in most cases, it's better to use more GCPs than just 3. So I would say at least 4, and then use your 5th one just as an independent check after the dense reconstruction has occurred, just to really know with a normal heart that your data is actually correct. Something interesting I want to show you is you'll see there's some small orange lines on the images. This is actually because we made use of a rolling shutter. So if we made use of a mechanical shutter, there would have been no shift on this. So the drone that was used is a Phantom 4, but it's a Phantom 4 standard, which means it's got a 12 megapixel camera with a rolling shutter. And because of that, there is quite a bit of adjustment that happens in 3Dsurvey, as you can see. Some big, some small, but that's what a rolling shutter does. That's why we always try to go for a mechanical shutter and not for a rolling shutter. Alright, so if you have done your processing without making use of any GCPs, it will look something like this. And again, we can just validate that the site is in fact correct and that there's no jumping images, especially because we're making use of RTK or PPK. We just want to make sure that the point cloud is stitching nicely together. Alright, we can see that nothing is wrong here. And now we can go ahead and actually check how accurate the survey was. On this survey, we used our base on a year position, so the data will be out by quite a bit, and we'll definitely have to do a shift on the total point cloud. So if we check and load some checkpoints, so we'll just say load some CAD, and then let's just load some raw GCPs. Again, point name, westing, southing with an elevation, and also on a known coordinate system. We're happy with that, and we can just say import. So this is the real GCP data as it was picked up in the field. Obviously, as we can see from this image, it's definitely not lining up correctly. So what we want to actually find out is see what is the true difference between the two, just to get a better and rough idea. So we'll go ahead and then maybe just add a point on top of the GCP there, and then just measure from this GCP to that GCP. Okay, so that is about 7 meters. So that's quite the adjustment that needs to happen. That is a 3D distance, so let's just redo that and make it a 2D distance just to get a better idea. So measure 2D distance, and alright, that looks a bit better. So that's 1.93 meters. So the point cloud is going to have to shift quite a bit. Let's just do another check. Maybe on one of these other points. So it comes down to, as you can see, there's my GCP. Again, it's not plotting on the correct space and place. So one thing that you will see when you use PPK or RTK data is that it's consistent, meaning that if your error is 1.93 meters, it will be the same more or less in all your points. As you can see, another 1.93 meters. So I'm happy to start doing the adjustment, and what I'll have to do is I'll have to detect all the points, do a comparison in Excel, and then shift the data at once. So because this is a webinar, we've already done this, and we can actually show you the results quickly. So as you can see, these are my GCPs coordinates. These are the true coordinates detected and picked up by the GPS. And these were my coordinates that we picked off the point cloud. So as we can see, there's quite a big difference in the points. So say anything from 1.872 to almost about 2 meters. And then the mean difference is about 1.92, which we actually saw in our images as well. It's about 1.93. So we're fairly happy with that. Mean on the X and then also mean on the Z. So jumping back to 3Dsurvey, we know that we have to shift this point cloud to get it as accurate as possible. So in order to do that, we need to go back to our point cloud function, say select, and then we actually want to select our full point cloud, or the point cloud or area of interest. So in our case, it will be the full point cloud, and we'll then see select on manipulate points. Over there, there's a move. So we want to actually move this point cloud with the same amount as in our Excel spreadsheet. So it's just confirmed. So it's 1.921. So we want to move this by 1.921, and our X value, we want to shift it by, say, minus 0.008, and our Z value we want to shift in as minus 6.922. So say minus 6.922. Sorry, 6.922, and we can confirm it. And there you'll see there was a slight adjustment on the screen, meaning that it has actually shifted my point cloud already. And I can then go back and just confirm where it is currently. So we'll just clear the selection. So maybe let's put off the CAD data and zoom into our first GCP point. For example, over here. Right, and if we select on the CAD, great, it's actually plotting in the center of our GCP. Our next thing that we need to do to actually see what is the results of the shift is to just do some basic measurements, and we can see that it is fairly good on the GCP. Let's just check another one. Okay. So what I'm going to do, I'm maybe just going to switch off some of this CAD functionality. And then just use it and see how our points are actually looking. Alright. And then we can maybe just do another check. Oh, we're checking the incorrect thing. Sorry. We just wanted to check the height. Now that's about 30 mils. So we're actually pretty fine with that. Just to zoom in a bit more. That's 30, 40. Alright, we're very happy with that. Let's just go back and check those previous points. You can actually check this point since it's falling on a new line. Okay, and we can just select it and then just drag it around, and again we can see that our accuracy is fairly good there. Just say, there we go, that's about 30 mils, and that's more than what we need. So as you go further away, obviously the topography changes and there will be different deviances, but as close as possible to the GCP, we want the results to be as good as possible. So 30 mils is definitely fine for what we want to do. And then just to do another arbitrary check, we'll go over to this point and then just check it to make sure that we're actually fine. Alright, so let's just click on the point. Again, that's about 30 mils, 40 mils. I think that's fine. That's what we actually wanted. We know the physical position is spot on. We just wanted to validate if the heights are as spot on as the position. So, and we're pretty satisfied with 20 to 30 mils. And we know this data set is now correct without processing or making use of any GCPs in our initial processing step. And as we can also see that there was no jumps in the data set. So if some of your photos have been processed incorrectly, this is the first place where you'll see it. Before you even load any validation or checkpoints, you will see that there is a definite step in your point cloud. I don't have a good example here, but since everything has came out very good, but if your points of your photos is incorrect, there will definitely be a jump or a step in your data, and you can clearly identify and see it. Also, when you generate your point clouds, if you do not do proper checks, when you do your contours, that is the first place that it will also pop up, and you can definitely see and identify it. So always good to use 3Dsurvey as a tool to generate point clouds, even if you use your own third-party software. Really good to just make use of it as well. So that was how you compare and move your normal point cloud without making use of a GCP. Alright guys, so as you can see that the processing is actually finished, and this is how our model is looking like. And we can just do a slight rotation on it just to make sure that all the photos is not responding incorrectly and that the data is not stepping. So as you can see, it's really smooth data set, which means all our photos aligned perfectly. So with saying that, we can now go ahead and do a bit of comparison. So what we'll do is we'll load some data. So let's go and load some checkpoints. Always make sure that we keep these points as westing and southing with an elevation, and we can always use our known projection because we actually have a coordinate system. As you can see, it's not wanting me to import because over here it's still expecting a value which is not getting, so we just have to make that none, and then it's able to import the validation or checkpoints. So we'll import that. And then let's jump to some checks and see what it says. So our first checkpoint will be 0.25, and what we'll do is we'll use the ruler under the CAD function and then just use the height method to check. So we'll snap there. As you can see, that's about 50 mils. That's about 50, 50, 50, 50, alright, 40. I think that's fair to say that that point is fairly good. And let's look at some other points. Alright, let's check this point. That's it. 10 mils, 10 mils. 20 mils, 10 mils. Alright, I'm very satisfied with this. And I think compared to our GPS data, we're pretty spot on. Maybe a last check we can do is perhaps checking 0.70. That's it. 2 mils. 1 mil. Alright, I think we're in the tolerance that we want for the survey. 30 mils, 40 mils, 20 mils. Alright, I think we're happy with that. So let's maybe just add some more GCP data so that we can see that everything is actually plotting correct on the GCPs. So let's say load some more CAD, and then we can perhaps just load. Okay, point name, again westing, southing with an elevation, and then always make sure that we select the known projection if you do have a known projection. If you don't, keep it on local. We'll say import. Alright, so let's maybe check some of our GCPs as well, as close as possible to our data set. Okay, that's about 10 mils difference, 20 mils on our GCP, and let's maybe just put off this checkpoints so that we have got something better to work with. I think let's just go to this point over here. Okay, that's 30 mils. I'm pretty happy with that. 30, 40, nothing wrong. So I can safely say that my site extents are correct, and I can see that my GCPs are in fact plotting correctly on my targets. So if you typically go and zoom in closer, obviously there's a white dot on top of the target, so it's difficult to see. But if we take it away, you can actually see there's the target. Place it on, you can see that's pretty much spot on in the center of the target. So we know that our PPK data is definitely correct, and we can go ahead and do a basic classification. So we'll do this classification, and I'm just going to make it a little bit less to 17. Say next. Right, click on my ground. As you can see, my classified section, which 3Dsurvey sees as ground, is all selected in red, and everything that it does not recognize as ground, it is still in the normal color as was generated by the point cloud. So this is good, and we can go ahead and say next. So basically what I want to do is I want to split the higher vegetation from the ground in order to generate the correct contours for my survey and my site. This is exactly what I'm looking for. Alright, I'm satisfied with that. So what I'm going to do now is I'm going to delete the other points, meaning the higher tree vegetation points. I don't need them. I don't want them. I just want the basic contour out of this site. So I'm just going to say delete other, and this will automatically delete my trees out of my point cloud. And then the next thing we want to do is create a mesh. So let's go to calculate a new DSM mesh, and over here you can see the point classes. If you keep everything selected, it will actually process your original point cloud as you've seen as well. But we don't want that. So we can maybe even make this 1 meter, and the hole filling we can just say all, and then our smoothing factor we can make that up to about an 8. We'll say calculate. Alright, there you can see a basic DSM model. Okay, so if you have selected optimized, everything would have been solid where there was holes before, but this was not our need for this project. So what we'll jump to do now is just to calculate a bit of contours in a 0.5 meter interval is perfect. Okay, and if we switch off this, there we can see a good and proper contour survey of the entire area. And this is exactly what we are after and that we would like to present to our client as final data. So one thing we want to just add is to create an orthophoto. A top-down orthophoto is perfect. Over here you can see the desired resolution. So this is my GSD. I'm fairly happy with that. I'm just going to say calculate. So as you see, the software always starts with a high time amount that it will take to finish a certain task, but as it progresses and it sees what is available on the PC, it decreases fairly fast to the actual amount it is going to take. So for example, if you process a point cloud at the beginning, you can get some data which says it might take 6 hours to process, but once you start processing, you'll see that gradually you'll be gaining time, and it might end up taking only 3 hours or 4 hours for a 6-hour job that it initially thought it would take about 6 hours, but it ended up taking 4 or 3 hours. So don't stress when you see that time at the beginning, and that's also why it's important to keep your PC on 24 hours to do your processing. So if you end up having to process your data late in the afternoon, by the next morning you know your data is set, and you can also set batch processing so that your computer will automatically do one thing after the other and end up with all the data in the morning, and you'll just be ready for the next job. So a good tool to maybe look at is to use your batch processing. Right, as we can see, my contour is actually flowing through my trees, and it's used my original photos for the job, and this is exactly what I wanted. And I'm fairly happy with this. So if you want to cut your job, you can also do this by using the cut function. If there's a specific area that you're interested in, say for example we're interested in the area from here to about here, we can cut out the rest. Over here you can see the maximum minimum coordinates and also then the differences. I'll say confirm. It will cut to the desired area that I've selected. And there we go. This is good, representable final data that we can actually provide to the client. What we can do next is we can also export the data. So if you export the data, you only have limited functionality. But if you go to the orthophoto setting in your tab and you say save as, you can actually save your file as something that you actually want. So we just create a to client folder here, to client, and then we'll just save this as an ortho to client, the revision of 00, because this is our first revision, and then we'll say we just want the KMZ file to be sent or saved. So we'll click on save, and max tile size, everything looks good. I'll save it again. As you can see, it says saving orthophoto, so this might take a few moments. Once it's done, it will automatically pop up in the location and folder where it has saved your KML file. A good thing to do then is click on that file, open up a Google Earth and see that your job is actually plotting on the correct space and place on Google Earth, so that you can actually send that data to the client. You don't want the client getting your data and saying to you, hey, I can't see where this is plotting, or it's plotting in the ocean. So always make sure that before you send your data, it is actually correct and plotting in the correct space and place. Okay, so let's go ahead and then just open this. So your first setup on Google Earth might always take a bit longer. And also your file size is about 70 megs, which is fairly big for Google. So it might just take a moment or two to actually load your file. There we go. So it's always advisable to have the minimal amount of software open on your PC and make sure that you have good and proper internet when you do this. So as we can actually see, when we press R on our keyboard, it will give us an exact top-down view of our area on our site, and we can see that it is lining up correctly, and we're very happy with the outcome that has been provided here. So if we're happy, it means the client will also see the data in the correct position and place, and we can then just jump to 3Dsurvey again. Alright guys, that's the end of the webinar. I first just want to say thank you so much for sticking around up until the end. And if there's any more questions that you have, please go to our website and reach out to us, and we'll be sure to answer you. If you would like to find out more about the technology, also visit our website and check out all the latest and greatest surveying technology out there. That's it for today, and I'll see you in the next webinar. Cheers.